All right, so we're going to kind of pick up a little bit where we left off and go over a couple of the different items and terms that you still need to know. We'll save some of the in-class stuff for next week, but let's talk a little bit more about the scientific process and different parts of it. And so we already talked about observation, so let's talk a little bit about variables. Now, variables basically by definition is anything that can change within an experiment. So you have two main types of variables whenever you're looking at an experiment. One is independent, which is manipulated. So that's what I'm changing in an experiment on purpose. Now, when I change something on purpose, I might be like, oh, what movie do I like the most? I'm changing what movies I want to watch. See, what makes me laugh the most? Well, which one makes me laugh the most would be what's called the dependent or the responding variable. So what am I measuring based upon the variable that I'm changing? And we have two different real types of variables. We can be qualitative or quantitative. Qualitative is typically those things that are not as tangible. So happiness, for example, might be a qualitative variable. Quantitative is more something numerical. How much is something? How much does something weigh? How big is something? How fast does it go? So if I measure something at a certain number, then everyone else should probably be around the same values for it. Now, we also want to talk a little bit about controlled. And so these are setting up environments where I'm comparing something in an environment where I'm trying to minimize all of the other things that could affect the results. So, for example, if I'm going back to what movie is going to make me happiest, I might want to make sure I'm not hungry before or the same level of hunger, or I had the same type of day at work. If I had a really good day at work, that could affect my mood as to how I'm watching the movie. So what I want you to do, and you notice in the sheet, this is one of your questions, is you need to figure out the following situation. Your third grade class wants to do an experiment to figure out what type of food the classroom turtle prefers to eat. You decide to test out lettuce, oranges, crickets, and oatmeal. So I want to know what's your manipulated variable, what is your responding variable, and I'm sorry that the webcam photo is covering up the last one, but what variables should you be careful to control? So why don't you pause this, go to the worksheet, answer those type of questions, and then when you're ready, hit the pause button and start the video back up. Now here's another one. So I included the link for this in the video, or in the worksheet rather, and you can sometimes ask questions and devise experiments based upon that. So do plants grow better when you talk to them? And Mythbusters actually performed this experiment. So in the video, you'll notice there's the link for it, but I attached the hyperlink in the worksheet documents. You can go watch that video at this point in time. Think about what are the variables in the experiment. How would you determine an answer to your question? What could you do to make the experiment more accurate? Again, sorry, it's covering it up. And then finally, what happens if the water runs out? So if all of the plants all had the water shut off for 2 weeks, all experience the same thing, would that affect the result? So kind of answer these questions in your sheets as well too. So why don't you go ahead and watch that, pause it, and come back. Now, we talked a lot about what science was and the ability to test things and try to prove them wrong. Well, what is science not? And it's a pseudoscience. Anything that claims to be scientific, but fails to meet the standard. So there's no evidence for it. You can't reproduce it. Astrology, for example, things that ask how. That's what science tries to do. But supernatural, religion, they go above the nature. They go why. Case in point, for example, I had a student several years back who was a ghost catcher, and I had talked about catching ghosts as being a pseudoscience. They might use scientific equipment, but you can't really test to see if the ghosts are there if they're not there. So I've moved that as to a what is science not. Now, something to think about is once we have science and we have an understanding of the world, then we need to get into technology, which technology is really the application of the science. And it's a difficult concept because if we ask you, is technology good or bad? Try to think of something where what makes it good, what's make it bad, and ultimately, is technology itself good or bad? And that's something kind of for you to think about and reflect upon. Now, in this class, try not to do too awful much math. There is going to be some, however, you got to understand that math is a language of science. Now, they are related, but don't get too stressed out if you're not good at math. You can still love the science and still do very well in the science. Math just kind of helps put a little bit extra understanding to it. And like I said, we're going to be here together to work on it moving forward. Now, a lot of times, there's some other things with language. You hear about science that there are scientific facts and scientific laws and hypotheses and theories, and we talked about some of them. A lot of books tend to make it sound like items and ideas and models start out as a theory, and then after enough time, they graduate to become laws. And that's not true. Newton's laws, for example, the key thing is that these pieces of information, our understanding of the world changes based upon the technology and what we're able to do. So Newton's laws, for example, were held to be true for the longest time, and we thought that they were a staple. However, that changed once we discovered relativity, and once we discovered when things move close to the speed of light, and then also looking at black holes, under those type of effects and very small forces, are dealing with atoms and things on the atomic scale. Newton's laws don't hold true anymore. So based upon the technology and understanding of how the world works, we always have to modify our models based upon what the technology tells us. And again, this goes back to the idea that data supports or doesn't support our models. So we also need to keep that in mind, that things do constantly change. And when we're talking about science, a lot of times when I'm reading a lot of the autobiographies, you get the different branches. So we talk about physics, chemistry, astronomy, geology, biology, earth science, environmental science, zoology. There's all these different branches. But in actuality, if you really think about it, science is interconnected. You don't really have just physics. You can't understand biology without understanding chemistry. You can't understand chemistry without understanding physics. You can't understand physics without understanding all of these other processes. So they are all related. And like I said before, this is one of the reasons why elementary schools are so wonderful, because they're already combining everything. You not only have them naturally inquisitive, but you have that opportunity to show the connections in your own classroom across the board. So we're going to do a couple examples in class about identifying things that are or are not scientific. So I kind of want to hold off in class to get those discussions going. So I look forward to seeing you in class next.